9.5 is addition, subtraction, and complex fractions. So we're about to take fractions to a whole new level. Really exciting stuff here. Our essential question is, how do you add or subtract rational expressions? And then just to add on to that, how do you simplify complex fractions? All right, so our first example is going to be a rather simple one. And the directions are just to simplify. So we are going to have, let's see, 3x over 2x minus 7 over 2x. So hopefully you remember with adding and subtracting fractions, the only way that you can do that is if you have like denominators. And in this case, I do have like denominators. However, my numerators don't have like terms. So what I need to do here is make sure that when I subtract these, you know, this can't be 3 minus 7. It's 3x minus 7. All over common denominator, so it's just your denominator. Now remember, x is not a factor of the numerator. It is a factor of a term of the numerator, but it is not a factor of the entire numerator. The only way that you can reduce out these x's is if you were able to factor that x out and have it being multiplied to the entire numerator. Okay? So this is going to be your final answer. That is completely simplified. That's all you can do. All right, let's look at B. So now I've got 4 over 3x cubed plus x over 6x cubed plus 3x squared. I can't add these because I don't have common denominators. Now, in order to figure out the common denominator, we want the least common denominator. That would be, you know, most appropriate, easiest to work with. So I need the least common denominator. And in order to figure out what that's going to be, I'm going to need to factor first. Okay, so let's see. Well, there's nothing here to factor. But over here, I notice that they have a common factor, right? Both terms here have a common factor of 3x squared. So I'm going to factor out a 3x squared, leaving me with a 2x plus 1. So in order to add these now, I'm going to need, right, I've got the 3x cubed, okay, but what I'm going to need here, let's see, I'm going to need another x here to make this 3x cubed, and then I'm going to need this 2x plus 1 here. So I'm going to multiply top and bottom here by 2x plus 1. Remember, as long as I multiply top and bottom, it's just like multiplying by 1. Here on this side now, I'm going to multiply by x. Okay? So on this side, I'm going to end up with 4 times 2x plus 1. And what I'll do right now, I think, no, I'll go ahead and I'll write it out. 3x cubed times 2x plus 1. Now on this side, I'm going to have in the numerator x squared. Oops, sorry, I'm off of this page there. X squared. And over here, let's see, this x, I can multiply it to there, and I'll have 3x cubed and 2x plus 1. Do I have common denominators now? I do. Okay, so what I'm going to need to do now maybe is distribute my 4 here, so that way I can add all that together. So let's see, and I'm going to leave the denominator completely factored. It's as factored as it's going to get. So I'm going to leave that completely factored. Okay. All right. So on here I'm going to have 8x plus 4 plus x squared all over my denominator, which is 3x cubed times 2x plus 1. Now I'm just wondering if there's any factoring that can be done here. So I guess that's going to be my next question. So I know that I can rewrite this as x squared plus 8x plus 4 over 3x cubed times 2x plus 1. And my question then is, can I maybe factor this so I get a 2x plus 1? Well, first of all, my first terms in both binomials, if I factored this, would have to be x's. I wouldn't end up with a 2x. And then my last terms would have to be 4 and 1 or 2 and 2, so I'd never end up with an 8. Okay, so this is completely done. There's nothing more that I can do. But you want to be asking yourself, is there any more that I can do? Okay, let's see. Let's try a more challenging one. I think I'll flip my paper over because it looks like the next one's going to be a little bit longer. So C. So we'll do x plus 1 over x squared plus 6x plus 9. And from that, we're going to subtract 1 over x squared minus 9. So the first thing I'm going to need to do in order to subtract these is get common denominators, and I want the least common denominator. I mean, if you like torturing yourself, then you can just get a common denominator by multiplying these two together. But that is a lot of work, okay? So instead, what I'm going to do is I'm going to factor each denominator first, okay? So I'm just going to do that right under, well, you know what? I better make good habits here. Let's go ahead and I'm going to rewrite the numerator. On the bottom here, I see that this is a perfect square trinomial. First term's a perfect square, last term's a perfect square, right? This is x, and this is 3. Those are both perfect squares. If I multiply them together and double them, I'll get the middle. So that's a perfect square trinomial, telling me that this really factors into x plus 3 squared. Now over here, I've got an x plus 3 and an x minus 3 because I've got a difference of 2 squares, so I factored into a sum and difference pattern. So what's missing here? Well, it looks like on this side I'm missing an x minus 3. So I'm going to need to multiply. Maybe I should write my equal sign out here a little bit more. I'm going to multiply this side by x minus 3 over x minus 3. And on this side, it looks like I'm missing 1, right? I've got 2x plus 3s here. So I'm missing an x plus 3. So I need to multiply by x plus 3 top and bottom. Okay, so in the numerator here now, I'm going to need to FOIL, right, or double distribute. Okay, so I end up with an x squared plus x minus 3x minus 3 over, and what I've got here is a, let's do an x plus 3 squared times x minus 3. Again, I wouldn't multiply this denominator out. It's already completely factored. So let's just leave it like that. That's totally fine, okay? All right, and then over on this side, I'm going to have, now this is going to be really, you're going to need to be careful here. So this is a negative or minus x plus 3. So I'm going to write this out in 2 steps, okay? Which, as you get better with this, you won't need to write out so many steps. But right now, I really need you guys to be careful. Okay, and then this becomes the same exact denominator. Okay, so now let's combine some like terms and let's actually write everything over one denominator. So I've got an x squared. Now this is x minus 3x gives me negative 2x minus 3. Now here's the trick. We are subtracting this binomial. So that means I need to distribute that negative sign. Okay, all over my denominator. Okay, simplifying that a little bit more. Let's see, I'm going to have an x squared. Looks like minus 3x. And then minus 6. All over x plus 3 squared times x minus 3. And I think that's as far as we can go. Again, I'm going to ask myself, can I factor the numerator? Well, it's possible I could get an x plus 3 or an x minus 3. So let's think about that. What are factors of 6? Well, it's 3 and 2. And is there any way to add or subtract 3 and 2 to get 3? No. You're either going to get 5 or you're going to get 1. So I am completely done. Okay, and then the next thing I want to show you. Oh, and I guess, you know what, let me write a little star here. Make sure that you distribute your negative. Okay, make sure that you distribute those negatives. Really important stuff there. Okay, the last thing I'm going to show you is a complex fraction. That means a fraction with fractions in it. So same directions, we're still going to simplify. Let's see, you're going to have 3 over x minus 4 divided by 1 over x minus 4 plus 3 over x plus 1. Oh my gosh, what a disaster. If you didn't like fractions before, well, you're probably not going to like this much. But what you really want to do, this isn't that hard, okay? I know you guys see fractions and you flip out, and now I've got like all kinds of fractions within a fraction. So what you really want to think about is what's in my numerator and what's in my denominator of the main fraction. So let's see, let me find a highlighter here. How about you think about this is your original fraction bar. So your goal right now is to simplify the numerator, simplify the denominator. Okay, so that's the first thing you want to do. Simplify numerator, simplify denominator. Because your goal is to get this as one fraction over another fraction. Because we can't divide fractions, but we can multiply the reciprocal, right, of the denominator. So that's what we want to do. So it looks to me like the numerator is already simplified. So it looks to me like the denominator needs to get simplified. Okay, so here, first thing. Simplify numerator, then denominator first. Okay? Then we'll multiply by the reciprocal of denominator. It's that simple. This is really not that challenging, okay? All right, so what I notice here is that these cannot be added together. They don't have like denominators, so I need the least common denominator. The only way I'm going to get that is by multiplying these two by one another. So over on this side, I'm going to multiply by x plus 1 top and bottom. So that's getting multiplied to this first piece, and then this other term here is going to get multiplied by x minus 4 top and bottom. Okay, so up here I've got basically 1 times x plus 1 over, oh, I should leave the numerator. Sorry, give me a minute. I got a little bit excited there. I was just working on the denominator. Okay, leaving the numerator where it is, so that's 3 over x minus 4. Now in the denominator, I've got 1 times x plus 1, which you don't really even need that, but I'll go ahead and put it in right now. And then we'll distribute. Over x plus 1 times x minus 4. Okay, and I've got a complex fraction here. And I'm going to add to that this 3 times x minus 4. All over, same exact denominator, right? Okay. Now leaving the numerator alone, but in the denominator, let's get rid of these parentheses, okay, and kind of add it all together. So I'm going to have x plus 1 plus 3x minus 12 all over the denominator, which is x plus 1 times x minus 4. So simplifying that, leave my numerator alone. So it looks like I've got 4x minus 11 all over that denominator. Now, if it's hard for you to see this, right, originally I put a green highlight where my main fraction bar was. So maybe I continue doing that. because maybe it's hard for you to see, hey, what's being divided by what here? Okay, so now what I've simplified numerator and denominator, completely simplified there. Okay? I mean, I guess you could multiply this out, but I'm not going to because maybe I can factor something out later. Okay? So what I'm going to do, I'm going to come back up here, give myself a little bit more room. This is really the same thing as, and you don't have to write this, but it might be helpful, divided by 4x minus 11 over x plus 1 times x minus 4. And if you've learned anything in all your years of math, it should be that we don't divide fractions. We need to multiply by the reciprocal, okay? So really what this is going to be, leave that numerator alone, okay? And now you're going to multiply by the reciprocal of this divisor, okay? So now I'm going to put x plus 1 times x minus 4 on the top, all over 4x minus 11. Okay, and here's an example where, in the denominator and in the numerator now, I'm multiplying straight across, but I have common factors, right? So my common factor, x minus 4 and x minus 4, those reduce to 1s. And I'm left with 3 times x plus 1 over 4x minus 11. Or in other words, distributing that 3, I get 3x plus 3 over 4x minus 11. There's nothing else to be reduced. I am done.